Hello, welcome back to the channel. And this video is again a part of the series One Move at a Time. इस सीरीज में हम जनरल प्रॉब्लम ऑफ द डे क्वेश्चंस को उठाते हैं आपके एनालिसिस करते हैं। आज का जो क्वेश्चन है वो काफी इंटरेस्टिंग क्वेश्चन है। ये क्वेश्चन गेट्स पे आज प्रॉब्लम ऑफ द डे है एंड दिस क्वेश्चन इज Floyd-Warshall Algorithm. So let's discuss this. What is this Floyd-Warshall Algorithm? What are the uses and how actually we can code it. Okay. So technically, third version is an algorithm for finding all pair shortest path. Basically, अगर एक आपके पास ग्राफ हो जिसमें कई सारी नोड्स है, हर नोड्स के बीच में अगर मुझे शॉर्टेस्ट पाथ आइडेंटिफाई करना है, the keyword be shortest path between each and every node, between each and every pair of nodes. If I have to identify that, then the algorithm that I'm going to use is actually this Floyd-Warshall algorithm. Okay, moving on to the next slide. Let's see what this algorithm is actually is. Okay, so what is the aim of this algorithm? This finds the shortest path between all pair of the vertices in a weighted graph. So if you have been given a weighted graph, then this algorithm will find shortest path between all pair of vertices. That's the thing that this algorithm is made with. अगर हमें पता है कि एक वेटेड ग्राफ है, हर एक नोड के बीच का आपको शॉर्टेस्ट पाथ निकालना है, आप सिंपली इस एल्गोरिथम को चाहिए, इंप्लीमेंट करिए एंड यू विल गेट द आंसर. एंड दिस विल वर्क फॉर बोथ डायरेक्टेड as well as undirected graph. Undirected graph के लिए कैसे काम करेंगे? Basically, you can just simply take an undirected graph and you can convert it to a bidirectional directed graph. So it will again like the many algorithms, it can handle the negative weight. तो अगर कोई एक ऐसी दो नोड्स हैं जिनके बीच में नेगेटिव वेट है, it can handle it, but it cannot handle negative weight cycle. एंड ये हमने काफी डिस्कस किया था लास्ट एल्गोरिथम में भी जब हम बेलमैन फॉर्म डिस्कस कर रहे थे कि इफ देयर इज अ ग्राफ व्हिच हैज अ नेगेटिव वेट साइकिल देन दिस एल्गोरिथम कैन नॉट हैंडल इट. द रीजन बीइंग इज वेरी सिंपल. अगर एक ऐसी साइकिल है जिसमें मेरा वेट जो है नेगेटिव होता है तो मैं उस नोड पे सिर्फ एक राउंड क्यों रुकूंगा? मैं सिंपली अगर मैं ए टू बी टू सी टू जाता हूँ, ए टू बी एंड देन बी टू सी एंड देन सी टू ए, अगर मेरा ये ट्रिप लग रहा है और उसमें मेरी कॉस्ट नेगेटिव हो रही है, so I can make this trip n number of times and my cost will keep on reducing. There is no limit to that. So if there is a graph which has a negative weight cycle, then definitely this algorithm will not work over there. You need to actually put in some constraints and maybe then you need to modify this algorithm. Then maybe it will work. So you need to put in constraint कि आप एक route पे कितनी बार आप एक round trip लगा सकते हो. Also अगर एक route पे मैं सिर्फ एक ही बार round trip लगा सकता हूँ, even then this algorithm will work in theory. But अगर मैं multiple times लगा सकता हूँ, then this algorithm is not going to work. Okay. To the next slide. What are the key features of this algorithm? Let's look at this. The graph is generally represented in this case as a matrix, and time complexity is OV cube, space complexity is OV square. अगर ग्राफ को मैं एक मैट्रिक्स की फॉर्म में रिप्रेजेंट कर रहा हूँ, टाइम कॉम्प्लेक्सिटी is definitely going to be b square, where b is the number of nodes. Okay. And what this algorithm does is, after this algorithm has completed, it will update the shortest distance between every pair of the node. This is what you are going to get as a now. Now let's look at the key idea behind the algorithm. Before I, actually read this, I would like to mention that I have simply picked this from Geeks for Geeks. I'm going to give complete credit to this website. So I have picked this content directly from there, and I'm going to discuss it. Also, what is the idea behind the algorithm? Okay. So the idea behind this algorithm is pretty simple. So let's say you have two nodes. You have a node I, you have a node J, and you want to find the shortest. Now, if this shortest path can be directed, but direct path, तो एक direct I to J का एक path हो सकता है. It can be the shortest, or it cannot be. For the case that this is not the shortest path, definitely there will be some node K जिसके through shortest path होके जा रहा हो. For sure. तो अगर जितने भी वर्टिसेस भी हैं उनमें से कोई ना कोई एक वर्टेक्स ऐसी होगी, वर्टेक्स के जिसको मैं कह रहा हूँ, जिसके थ्रू ये शॉर्टेस्ट पाथ जाता हो। तो अगर मैं एक वर्टेक्स के को आइडेंटिफाई कर पाता हूँ, देन डेफिनेटली आई एम गोइंग टू गेट माय आंसर। सो इफ देयर इज एनी वर्टेक्स के जिसके लिए the distance from I to K plus the distance from K to J is actually less than the total cost from I to J, then definitely this is the shortest path. Okay, and I'm going to admit this is a very simple idea. Okay. Also, when I'm saying the distance from I to K and distance from K to J, मैं assume करके चल रहा हूँ कि मेरे पास I to K की shortest distance पहले से है, मेरे पास K to J की भी shortest distance पहले से available है, और उसका यूज करके मैं shortest distance निकाल रहा हूँ. Okay, so that is the main idea. The main idea is the assumption that I have the shortest distance from I to K and from K to J, and on the basis of that, I can find the shortest distance between I and J. Okay, let's look at the algorithm steps. The algorithm steps are pretty simple. It's one of the most simple algorithms to implement. The core logic is that if the distance from I to K plus the distance from K to J. So if this distance from I to K and the distance from K to J is actually smaller than the distance between the nodes I and J, I'm simply going to update this distance. That's the core logic that you okay. And how you are going to do this, that's we'll see. Basically, मुझे क्या करना है? मुझे हर दो पेयर के बीच में आप shortest distance निकालनी थी. I had to find the shortest distance between each and every pair. So these two loops are actually iterating over each and every pair. So for node I and the range of all the vertices, for node J in the range of all the vertices, what I'm saying is that I'm going to run this core logic. And what is the core logic? That I'm going to take each and every node K as an intermediate node, and I'm going to see if the distance is somehow minimized. Okay, if the distance from I to K and K to J is somehow less than the distance between I and J. This is the core logic that I'm going to do. Let's look at the studio code. The studio code is pretty simple. It's the very basic code. What I have done is that here you can see this is my first iteration. Here I am selecting the intermediary node. यहाँ पे इस लूप में मैंने एक नोड k को चुना है, and what I'm going to do is I'm going to see कि क्या इस k नोड से कोई एक ऐसा पाथ जाता है I और j के बीच में जिससे उसकी डिस्टेंस कम होती है. So now what I'm going to do is that I'm going to take this node as an intermediate node, and for each and every pair of I and j, I'm going to see if this condition is somehow satisfied. If the distance between I and j is somehow uh, greater than, if it is greater than distance from I to K and from K to J, then I'm going to update it. So that's why I'm taking minimum distance. And this I will do for each and every pair of node by taking each and every node as an intermediate node. So in this example, you can see that there are three loops and each and every loop is running to the number of nodes. So basically the time complexity of this algorithm is enough. I had planned कि मैं एक dry run करके दिखाऊंगा, but I don't think the algorithm is very simple. You can always see it by yourself. I will, however, show you that what does it mean to be a negative weight and negative edge. Now, see, if you look at the first graph, you can see that there's a negative edge in the graph. Now, this algorithm can actually handle this negative edge because even if it goes in a loop, the weight is not going to be zero. But if you look at this graph and the second graph, then you can see that I have this loop, this circular path from node 1 to 2, from node 2 to 3, and from node 3 back to 1, where the total cost is actually negative. It's actually minus is 5, which is minus 1, minus 1, minus 2. Minus 3 is the total cost. Now, it's such a graph I cannot use Bellman for it. Because logically also it does not make sense. If you traverse this graph logically once, your cost is going to decrease. But you can traverse it again and your cost will decrease further. So there is actually no limit to how many number of times you can actually traverse this graph. Your cost will keep on reducing. Unless and until there is someone who imposes a restriction that okay, you can traverse in cycles only once, only twice, or only k number of times. Only then, for such a problem, you can find the minimum path. Okay, moving on to the next slide. Let's see what are the applications. Applications, because again, this algorithm finds the shortest path between each and every pair of the node. It will be used in domains like routing between communication networks, because you need to find the shortest path between each and every node in this network system. Again, if there is distributed system, you need to find the distance or the cost of sending information between each and every node or each and every device. And similarly, in game development and AI navigation also, this will be heavily used. So that was about this algorithm. Let's just revise the summary. What is this algorithm? This algorithm is basically a dynamic programming algorithm. And what it does, it finds the shortest path between all pair of the vertices in a weighted graph. Again, see, this is important that it finds shortest path between all the pairs of vertices, between all the pairs of vertices in a weighted graph. This is actually important. Okay. So between all the pairs, it will find them the shortest. How it works? It works by updating shortest distance between each and every ij by checking if there is a path through some intermediate node k, which gives us the shortest path. तो किसी भी एक k node को उठा के ये देखता है कि क्या उस k node के थ्रू कि कोई एक shortest path मेरे पास है कि नहीं है. अगर मेरे पास एक shortest path है तो ये उससे अपडेट करते हैं. टाइम कॉम्प्लेक्सिटी ओ v of q, क्योंकि हम एक बार हर एक नोड को ले रहे हैं एज एन इंटरमीडिएट नोड बनाने के लिए, और एक बार हम उस नोड को हम चेक कर रहे हैं फॉर एवरी पेयर. सो इट्स लाइक n into n square, which is n cube. Okay, that's the thing. So that was for today's video, and thank you everyone. Before I end, I would like to give the credits to Geeks or Geeks, ChatGPT, and the slide school for helping me in creation of this video. Thank you everyone.